You guys, can you all hear me? Everyone? Okay. Thank you for confirmation. In the last class, we were working upon the concept of a CNN topic, right? So first, we'll discuss two small topic that is loss functions and activation function. Okay. So we have so many activation functions available in your deep learning processes. Okay. For example, sigmoid, step function, right? Along with that, ReLU, leaky ReLU, Chan Hatch. So let's see one by one each of them. So I'll share the screen. No problem, Jean. You can continue. Always, you can see the screen. Kindly confirm. Okay. Fine. Activation function. This is the topic we are going to work on. So you have seen we have used activation functions a lot in every deep learning processes, right? ReLU, sigmoid, likewise. Okay. So the first activation function I'll discuss here is step function. First, let's understand what activation functions are. So definition here could be, in simple terms, an activation function in deep learning deep learning is like a switch or a gate that the flow, controls the flow of information, controls the flow of information through each neuron. So you have hundreds of neuron guys in a network, but all neurons will not get activated. Means the output of every neuron will not be considered. That is called as neuron will be firing or not firing. So there has to be a certain threshold which every neuron has to cross. If neuron is not crossing, that neuron will not be counted. Okay. So that threshold or limit is actually called as your activation function. Or you can write here an activation function determines determines the criteria for firing. Criteria for firing. Okay. Yeah. If your neuron output exceeds a certain threshold, okay, it exceeds a certain threshold, then only neuron will be called as fired. Means it can send the information signal to the neurons in the next layer. See, neurons are connected. You have seen these are network layers. Yes, Hina, we are working upon the topic called as activation function. Okay. So see, neurons are connected to every other neuron. You say this neuron got fired, then only it can able to send the information to the other neuron. If this neuron is not fired, then their output will not be considered for the next neuron, right? So for better communication, these neurons should get fired, and if only possible when they are getting activated and crossing a certain threshold here. Now we have said various type of activation functions here, guys. So the first activation function we will discuss. First is step function. So I will use one graph. Okay, I'll take this from Google. Let's take this graph. Yes. This is the graph for step function. Uh, Fired means neurons will get activated, means their output will be considered. Okay, Hina? Otherwise, that neuron will of no use because we have multiple neurons, right? So the neuron will be only considered when their output will be considered, means they are firing up. Now, step function means, guys, look at the graph here. The simple condition is if your x is greater than or equal to 0, then output is what? 1. Then your output is, see, this is 0. This is x-axis and this is your y-axis. If it is more than that, see, for that your y value is what? Constant. For 0 and more than 0, the y value is 1. And if the x value is less than 0, then output is what? 0. See, if your x is going, see, this is x negative. If x is going in this particular direction, see, your y value is, your y is not increasing, your y is 0. Right? Simple solution is if your x value is more than 0 or equal to 0, your y is 1. And if x is going in this direction, means for negative value of x, means x, if x is 0, your output will be what? Your output will remain 0. This is called as your step function. Clear, guys? Step function, everyone? Inform me in the chat box or mic. Clear?
So basically, X is moving on the right direction, and that's positive, right? And that is
Hmm.
making Y move
As 1.
on the positive direction too.
Yeah. That will be
Okay,
indicating the neuron is fired. Means 1 means fired. Correct? And if the
okay,
value of x is less than 0, the neuron will not be fired.
okay. So basically, if it's gonna go on the left and that's a negative X, so Y
Mhm.
is gonna turn into negative too.
Yes. Second is, guys, sigmoid function. Sigmoid functions you have seen already, right? Y equals to 1 upon 1 plus e to the power minus x, right? Have you seen this equation, guys? Everyone? In the logistic regression, okay, class, you have seen these equations already. So here, if I plot the graph, this is 0, this is 1, this is y, this is x. So your graph goes like this. This is 0.5. Okay. If your x, if your x, see, this is positive x, this is negative x. If your x is equal to or more than 0, then your y is what? See, think like this. It should say here y. If y is more than equal to 0.5, then the output is what? 1, because everything it will categorize into 1. And if y is less than what? 0.5, the output is 0. This is how we understand. Means 0.5 is the threshold. Let's say you have, see, this is the threshold, guys. So if
Govind,
you
it is
point it,
X or Y?
see, I'm counting it for y here because if you keep, because see, x can be infinite or minus infinite, right? And that x I will putting here. See, x will be used here. When you use x here, then y will produce some result to you, right? And for that y, this is the condition. This is two-step condition. You can provide any value of x because x is very much open. See, it can go in positive side or x can also go in negative side. So when you pass x in this formula, this y will produce some result. After that, you have one more step. If the value of y is 0.5 or more than that, then neuron will fire, otherwise the neuron will not. Okay? So it will be used, but in this equation. Clear?
So here it is f of y is 1 or uh, see neuron will be fired in the sense
Yes,
if
yes,
y
f
is
of y.
greater than f
Yes,
of
yes.
y.
Yeah, f
Okay.
of y this is. So f of x will be used here. Correct? This is f of x and this is f of y. This is called as, guys, your sigmoid function. Actually, in all these equations, there is something called as vanishing gradient. Okay, one problem exists here that is called as vanishing gradient. I'll discuss that. See, if you see, guys, take for the y. Your y has a range 0 to 1. Y has a range 0 to 1. After certain point, see, after certain point, your x is increasing, but your y will not increase. Yes or no? Here also, see, guys, your x will be keep on increasing, but your y become stagnant. It will not increase. This is called as vanishing gradient problem. When your x is keep on increasing, and for that change, your y is not changing. That situation is called as vanishing gradient. So this is the problem we have with the sigmoid function. The same problem you have with the step function also. See here, in the step function, you will also have the same problem. Your x is keep on increasing, but for every positive value of x, your y is what? Constant. That is y. Here also, for every negative value of x, your y is constant. That is 0. Getting, guys, what is vanishing gradient problem? I just write here. So it is a situation when our input is changing. But for that, the output is not changing. Okay? This situation is called as vanishing gradient. Now, we'll talk about the next sigmoid or next activation function called as tan h. Tan h means tan hyperbolic. Okay, tan hyperbolic. This is called as e to the power x. I will write the formula here. Tan hx. This is h. H stands for hyperbolic. E to the power z, or you can write x minus e to the power minus x, then e to the power z plus e to the power minus. Let's keep x everywhere. This is the formula of your tan hyperbolic. And E is called as Euler constant. How much? 2.71. Okay, this is the value of E. If I plot the graph of this tan H also, okay, this is called as -1, this is called as 1, this is x-axis, this is y-axis. Here, the range of y -1 to +1. See, this is the range of y. Here you also find vanishing gradient problem because see, if your x is keep on increasing, but after a certain time, okay, your y will stops increasing. Okay, this is the graph of your tan hyperbolic and range is -1 to +1. Guys, understood the formula here, all of you? So when you apply the network part, that time, see, you remember the formula or not, does not matter. You only remember the name of the activation function. It's just that I'm trying to tell you, behind the scene, these kind of mathematical formulas are involved. Hmm. The next one is ReLU, ReLU, code. So somehow it solved the problem of vanishing gradient to some extent. Okay. So if I show the graph here, first write the formula. Value stand for max 0 comma x. Okay, this is the formula of ReLU. Stands for rectified linear unit. Okay, by the way. See guys, in the positive side, see, look at this side. This side, if your x is increasing, see, your x is increasing, your, so your y is also increasing, right? If you check here, if your x is increasing, your y will also increase. So this side you don't have a problem of vanishing gradient. But if you come to the negative side, for negative value of x, your y is what? 0. Are you able to understand this, guys? So this side you have a problem of vanishing gradient because for every negative value of x, you have same y. But here, if your x is increasing, your y is also increasing. This is called as rectified linear unit. Now, let's
So
understand
Govind,
this formula. Hmm.
Govind, one question. So basically, I was studying ANN, and in ANN, when we were making the model, there was activation sigmoid and activation ReLU. I made both the models, so my accuracy was more in the ReLU. So these are the back-end processes that we have to
Yes,
understand.
yes, yes. But many times they will not be asked, but you should know what goes behind the scene, what is the formula being applied, okay, in different
But
activation
but
function.
which is better?
I'll just give a conclusion at the very end, okay? In the
Thank you.
testing process, what basically we will be using because it's a confusion because we have so many activation functions when to use what.
Got it.
Now, guys, here your formula is see ReLU equals to max of 0 comma x. How can you understand this formula? Listen, let's say your x value is 5. What is your y? Maximum of 0 comma x. What is y here? Tell me. In place of x, what you put? 5. What is maximum of 0 comma 5? 5, right? So for C, for guys, positive value of x, whatever positive value of x you will be having, that is the value of y. Because if you keep here 1 also, your y become 1. If you keep x as 100, your x become 100, your y become also 100. But what if you put minus 5? So y equal to max 0 comma x, y equals to maximum 0 comma minus 5. What is maximum here? Tell me guys, minus 5 or 0? 0. You
0.
see, for negative value, for every negative value of x, your y is what? 0. And that's what we have seen in the graph also. For every negative value of x, your y is what? 0. Clear formula? Now, and others.
Yes, I understood that part. But I was just thinking about if we have a zero constant for x value and the y value is decreasing, so how we gonna, it can situation
That,
like that too?
that is, yes, that is the next one. Very good.
Okay.
You anticipated in advance.
It's just a
This is one
thought.
next
Mhm.
one. We have rectilinear leaky value. It is max 0.5, 0.1, x comma x. This is the formula of the leaky ReLU. So here, let me just discuss the case first. If you x equals to 5, positive value, here you put x equal to minus 5, y equals to maximum 0.1 multiply 5 comma 5, 0.5, this is 5, y equal to, what is maximum here? 5. So in positive case, there is no problem. Whatever value of x you will be taking, that is the value of y also. But let's see the negative part. Maximum 0.1 multiply minus 5, and this is minus 5. This is minus 0.5, and this is still minus 5. Which is maximum here? The bigger number you have in negative, it is the smaller number actually. So this is my maximum number. See, 0.5. You see, your y is also changing. For every negative value of x, your y is changing. Yeah, it is changing by very less amount, but still it is changing. It is called as leaky value. In previous case, for every negative value of x, your y was become 0. You have plot the graph here. So positive side, there will be no change. And for negative side, previously it was on the flat side, but this time it will be like this. It will be a bit increasing, not on a flat side. This is the negative value of your x, your y. Okay, will keep on changing also. Clear everyone? This graph? Yeah. Which one to use? Guys, one more we have actually called as sigmoid function. Not very used frequently, but sorry, softmax. Actually, let's say in your sigmoid function, you got the output as 0.54, 0.76. This is the output in your sigmoid function. What softmax does, it will convert this answer into probability distributed answers. Yes. So how it will convert? So what softmax does, it will take 0.54 upon 0.54 plus 0.76. Second case, 0.76, 0.54 plus 0.76. Tell me the answer in both the cases. Everyone, compute the result. Same. Now, if you add these two numbers, see, if you add these two, you will see the answer is 1. And 1 is the maximum value of probability. So that is the main difference between sigmoid and softmax. Sigmoid gives you the normal result, okay? But if you want to convert that result into probability distributed format, just a little bit change, okay? So that time softmax will come into picture. So sigmoid and softmax both are almost same thing. Therefore, I explained you in detail here. So guys, now conclusion. In hidden layers, it has found in the testing process, we will be using what? ReLU. Hidden layer means input layer also, because the first input layer is also called a hidden layer. You will always use ReLU. And in output layer means the last layer, you will use sigmoid or softmax. This is something you have to remember. how testing has happened, something is something in detail we have. But yeah, in short, this is something we will be using for all future processes. When it comes to other sigma other functions, you should know what they are all about. But this is the conclusion for every activation function. So I'm giving you a quick note. Just visit it. You glance it once. Lina, yesterday you were not there in the class, I think.
Yeah, Govind, I went out, so could not able to attend.
Okay. Please have the recording of yesterday class, because we discussed one important network, that is CNN. We discussed their theory, math, and practical part also.
Okay, I'll check with Ujjwal. Thank you.
Please find the notes I have given in the chat box. Please revise this.
Govind, quick question.
Yes, tell me.
So, can I share my screen?
Okay, sure.
Okay, just one moment.
I'm giving the access first, okay?
Okay, hold on.
Yeah, I gave you the access of panelist. Check that.
Okay, join as panel. Okay. Yes. So let me just share my screen. So it's coming out. Just one moment. Can you see my screen?
Yes, I can see it.
Okay. So my question is this, like when we do it normally, when we are doing the confusion matrix and others like accuracy score in the previous models, but this is ANN. So this is tf.math or under dot confusion under matrix. So we have to put labels. Is it necessary,
Yes,
or we can
it is the
just put
attribute. It is the attribute in labels. You will put the actual output.
it is the actual
In
output?
labels, yeah, actual output, which is your Y test.
So if we just put y underscore test and y underscore predicted as you've
No,
done
no, no.
before,
That is for something we were using from sklearn, right?
yeah,
But here you have a change. You are not using sklearn. You are using keras for that.
here ask for that. Okay, so we have to memorize this syntax.
Yeah, yeah.
Okay, and one more thing. For example, now this is y underscore test is coming in x axis, or this is in the y axis. So why then we are putting predicted into x and actual into
It is
y
just
label?
for it is just for the label, so that your graph looks good.
No, no. So
So,
basically, my question is this: like, if we put y label as predicted and x label as actual, will it be wrong?
no, it will not be wrong. Either way is fine, but the sequence will be correct. Let's say if you're starting with 0, 1, 2, then actual side. Then you should start also in the British at 0, 1, 2. It should come like 2, 1, 0. Same order you have to be given.
Yeah, because my
Or
my understanding is this: like the first x-axis is predicted and y-axis is so y test is actual. So yeah, I was just having some confusion, but thank you for letting me know.
see, in any of the axis, you can put the actual and predicted. Okay, but don't change in the formula. If you want to
Yeah, yeah,
understand metrics in either order, both is fine.
yeah, but we
But
don't have to change the formula.
yeah,
Thank you.
let's say you are putting 0, 1, then on another axis it should be also 0, 1. It should not be like 1, 0. If you are starting from 1, 0, then other should be also 1, 0.
Yeah, yeah, makes sense.
See, listen,
Okay.
listen, wait. Uh, see, let's say on the screen
Yes.
0, 1 if you are putting, then also put 0, 1 here. If you are
Yes,
starting
yes.
with 1, 0,
In same
then
sequence.
other will be 0. Yeah. If you put 0, 1, it is wrong.
Yes,
Put
makes
1,
sense.
0. So either way is fine.
Okay, thank you. Thank you so much.
And guys, my voice is clear. You able to hear it properly?
Yes,
It is giving echo any sort of or not? No?
it was giving echo before, not now.
Okay, fine. Is completed everyone? Done with the revision? Okay, good. Okay, we discussed about loss functions already. Okay, so I'll just give a quick idea about loss function here. Can someone explain what is loss function?
Hi. So, as I understand, a loss function is a function that you're trying to usually minimize. For example, cost. If someone is running a business, they usually want to minimize the cost of labor and equipment, etc. Or I mean, it's possible that you can also maximize something, like maximize profits, but uh, loss function is usually you take all the inputs of your process and you try to optimize, either minimize or maximize. And often this is in the context of economics.
So when the actual output is not equal to the predicted output, then the difference can be minimized using loss function.
Correct. So anyhow, we have to reduce the loss, right? It's an error between the actual and predicted value. In machine learning and deep learning, loss function is a mathematical function that measures the difference between the actual output and predicted output. Oh, that is the meaning of your loss function. Now, it quantifies basically, guys, how well or poorly your model is performing. So the goal during the training process is to minimize the loss. Thereby, you basically improve the accuracy of your model. For example, mean square error basically used for regression, cross entropy and log loss we use for classification. So I'll just put here. See, the first one, you have so many loss functions, guys, but we'll not discuss each one of them. The one which is frequently used, we'll try to understand. The first one is mean square error, MSE. Do you know the formula of it? Because we discussed already in the machine learning processes.
Square root of y2 minus y1 whole square.
Square root is not there. That
Yes.
is for RMSE.
Okay.
First of all, y
Y2
actual
minus
minus y predicted.
predicted.
I. Okay, because they can be 100 of data points. Square upon n. I can be starting from 1 to n. This is for mean square error, MSE. Then you have RMSE. It stands for root mean square error.
Square
Same
root
thing you will be having actual I minus y spread I
1 by 2, right?
1 to n. You can just write here square root. Correct? That is 1 by 2. Next one is MAE. Do you know MAE means?
Mean absolute error.
Mean absolute error. So instead of square, you will be having mean value. Y actual minus y predicted. You will be having the absolute value. Okay. That is the meaning of your MAE, mean absolute error. Fourth one, log loss. So guys, it's also called as binary cross entropy. So basically, you will be, in short, I'll tell you, when you have binary output, okay, when you have binary output, then only you will be using this particular log loss. Okay. So for example, I write here, it's a bit tricky. So listen, minus 1 upon n summation you can also start from 0. Okay, that's not a problem, guys. Yi, okay, so I'll just put here y actual I. So again, it will be a problem here. So I'll just make one quick notation here. So guys, yi means actual and yi hat, it is for predicted. Okay, it will be easy for me to write. So I will write yi means y actual log yi hat log of y predicted plus 1 minus y actual dot, that is multiplication, log 1 minus y hat I. Okay, this is the formula for log loss or binary cross entropy. Okay, notations I have given. One more loss function you will be using, but not very much, but you can use it. That is sparse categorical cross entropy.
We use that in ANN, right?
Yeah, I have used that. Fifth one. Basically, when you have multi-class classifications, okay, that time we use sparse categorical cross entropy. So basically, we use it for classifications task. Okay. And if I write the formula here, it will be 1 minus n. And then log of pi, okay, and then yi. What it means, I will write. So when you open the internet, you will find some other notations also, but formula will be same. Okay, people can write other notations also. So here n stands for total number of sample, right? Total number of sample PIYI, it is nothing but the predicted probability of the true class. Predicted probability for Y actual. True class means Y actual. Or you can simply write for more clarity for true class. And then log, if you just compute, okay, in a single go, log PIYI, then you will be taking the logarithmic, okay, logarithm of the predicted probability for the true class. True class means when your actual and predicted are just matching, correct? I think anything else? One, two, three, four. Yeah, these five are sufficient because we will be just using it, okay, for all the deep learning processes. So one important point here, you will use for binary, okay, and when you have so many classes, okay, multi-class, you can use it. So the first three is for regression type of problem, MSE, RMSE, and MAE. When you compute the loss of regression type of problem, you can use first three. And when you want to use for classification, okay, you can use this one. When you have double two output, okay, binary, when you have more than two output, you can use this one. Just quickly have a look at these formulas once. I'll just delete the notes I'm giving once again. Just click on the link. You will again able to download the fresh notes. Check it. Jean, it was not on ANN, it was on CNN actually. So tell me, what is the problem you have? You have the mic access. Please tell me.
Yes, so I was checking my accuracy when I ran NN, and then on the 5 epochs I only had up to 10%. And when I made them 10 epochs, so I also had 10%. I think I couldn't even get the values for loss, but the accuracy was too low. Why was that?
Means
Did
when
you
you have
do
increased,
standardization?
Right?
Sometime it happens, like I've
some,
seen in
yeah.
tutorials, standardization was not done probably. Divided by 255 for X train, X test.
Just to convert them.
We have to do that. Govind can tell you better, but I think standardization was not done.
So it was not done in the hands-on, Joher?
Yeah, it
No,
wasn't
I'm
how.
saying I think he's doing model 2, but in model 1 you have done the standardization divided by 255. I think Gene has missed it probably. Because I've seen one of the tutorials. This
Share
problem
the
occurs.
screen. Share the screen, Jean, if you have hands-on with you.
Yeah, I need to share my screen better.
Okay.
Do I have authorization to share the screen yet?
I'm giving you the access. You have it now.
All right. It's gonna be my screen too. Right? You're able to see it, right? So this is it right here. See that?
No, I can't see your screen. Just share
Don't
it
see my,
now.
just my desktop.
No, I don't see your screen. Just share it once again. Click on share button with the green option over there.
What are you seeing? Are you seeing my desktop? Because I
Nothing.
already shared the screen.
I did not see anything yet since you have not shared anything.
I shared my second desktop. Okay. All
I
right.
can see.
Now you can see, right?
So tell me what you're asking now.
So I'm asking about this, right? Okay, this is gonna take some time if I run them again, but this is the result I was talking about. So this accuracy is not right about this model, right?
So your accuracies keep on dropping. I think it is dropped at 10%, right?
No, yeah, actually it was kind of increasing at some point after I made the epochs 10, but before when it was 5, it was the same results. But it looks like the CNN model was the best accurate on this
Yes.
project.
It is the best accurate one. That is what the comparison we did between ANN and CNN. So for
Yes.
image processing data, okay, whenever you are having, better to go for CNN rather applying ANN models.
Yeah, I understand it was I mean this is based on the random values, but at least I could have gotten something like 35% or 30% or 40%. But here I got 40,
Change
70.
the yeah, you can just do some experiment by changing the number of neurons or changing the activation function. Like so, optimizer you have SGD, you can change it to Adam,
Okay.
or you change the number of neurons in each layer. Okay, these type of tweaking you can make.
Yeah, I'll try play with that when I'm off
Okay,
the screen.
you will, yeah, you will, when you try, you will find some different values of accuracies and all. Okay.
Right, right.
You guys, everybody understood about the loss and activation functions, whatever we have available with us, the hands-on. Okay, these kind of activation and loss function we will be using all together.
Quick question. Can you explain more about the criterion we normally try to use those loss functions for?
Criterion, which criterion? So see, that's the first three is basically for regression. You can use any one of them, but I'll prefer to go for MSE. Okay, in every situation, MSE or then RMSE. And for classifications, you have other loss functions also, but these two are the one which are best and people use it is always. When you have two output binary classifications, go for log loss, otherwise go for Smart's categorical cross entropy. Okay, Jay?
Yeah, correct. Yes. Those first two, you said we should be using them when at what kind of conditions? Because like the mean square error, root mean
It
square
is
error.
all of them
In
are same
regression.
actually. See, they all does for regression problem because see, RMSE is something connected with MSE,
Yeah,
right?
that's yes.
And you are just making one square root. I did not find lot of places. I did not find a lot of situations where people using MAE because MSE and RMSE is smart enough to tell you the situation of the model. Okay.
All right. All right. Thank you.
Is any other question?
Govin, one question. See, in the notes you gave the conclusion part, right? So in the hidden
Hmm.
layers, it is using ReLU and the output layer sigmoid function. Uh, that means it is always use the ReLU in the hidden layers.
Yes, yes, of always, without any doubt. You can put always. I gave a one simple reply so that you don't feel confusion whenever you are implementing the activation functions for different layers. Okay.
An optimizer would always be Adam, or we can change.
You can change Adam, SGD. These are like optimizers who will help your model to find the better value of your weights.
Hi. I just have a quick question. I noticed that you did not include R squared in the regression loss functions. I mean, is there a special reason, or is it not considered a
R square is not a loss function; it's an accuracy. It is
okay,
used for
okay,
accuracies.
okay, thank you. I mean, because in the project, in the scikit-learn project, I mean, I didn't rely on R squared to judge
Mhm.
the models, but I did compute it, right?
Mhm.
I
So
did.
okay, I was just curious about that. Thank you.
This for performance side of accuracy. Okay, not in the error part. Okay, guys. So after this, we will be doing one more hands-on. Okay, that will be for on different data set. So let's have a quick break. Then we'll discuss about that. And if you are coming early, just please revise your ANN hands-on because on ANN only we will be implementing that. Guys, you all are there, everyone? Okay. So I'm sharing you one doc file in the chat box. So guys, I have shared one file link to you. If you open that, if you open, you will find 3 files on it. Can you see it? All of you in your system? Is the link can you able to open? Just confirm me if you can see the link in your system also and open it. Okay. So it has 3 files. Okay. Don't open the first file. Okay. This is the task. Okay. This is MNIST dataset. It's in the PDF format actually. So wait. So just open only this file, the center one, assignment one. Open this file. So you have to implement ANN, artificial neural network, on this particular data set. Fashion MNIST. Everything is given, okay, in this description file. The way you have implemented, okay, your normal ANN for MNIST dataset, same thing you will be implementing for Fashion MNIST. And if you are stuck somewhere, then only you can refer the solution. Okay, this solution is a PDF format, and this was in the IPYNB or collab format. Okay, this is your main file actually. Please read this file, okay, and start implementing it now.
Govind, can you please share yesterday's notes and also the
I'll share the zip
notebook
file
file?
to you. Okay?
Sorry, did you share?
I'm sharing a zip file to you. Okay, that zip file will contain everything. Okay.
Okay, thank
But better if you watch the recording also. Okay, it would be great.
you. Yeah, it's not uploaded yet in the training.
Okay. Check. Can you see it?
Yeah, one second.
Please read the description and then ask me, guys, if you have any questions. First, read this PDF file, all of you.
Yeah, I don't see any problem with the
Sorry.
I don't
Okay.
see I don't have a problem with the assignment. I mean, with the problem statement itself.
Okay, perfect. So please open a collab file, okay, fresh collab file, and load this data set and start working on it. Okay, do it quickly. And you will also receive an assignment for the weekdays, okay, where you will be working upon CIFAR 100 data set uh, to implement a CNN model over there. Okay, do you have everything is good?
Yes, I'm working on it.
Oh, yes.
Hina, what about you? Are you able to understand it?
Yes, I'm just finishing reading the assignment, and I have seen that there is a solution too. So if we have a problem, we can refer to that. I was
But
gonna
that is
say
not
that the
perfect.
project previously you have given, I didn't submit yet. I was so behind, but uh,
The link is
I'm
still
gonna
open. The link is still open. You need to submit because at the time of certifications, these project count will be required. Okay.
sure. I'm gonna say like I know I will submit first, but you will give the solution after that too for that. So if we need any help for referring, so we will have the same way basically.
No, no, solution will be given once you submit it.
Yeah, after submission. That's why I'm
Yeah,
saying it. You will give the
yeah, I
solution
will
for
be
that.
providing. I will be
Okay,
providing. No issue.
that will be great. Thank you.
What is the name of the data set again?
The one you are doing now, which one?
Yeah, the one for the fashion mixed.
Yeah, fashion eminist.
Okay, I trying to see if, oh yeah, I found it. It's just pulling it up right now.
And this is one of the task was being asked in one of the interview, okay, in the technical round. Okay, so this is something you are solving a interview round question of a company. The same statement was given. Okay, the time was given for around 25 minutes to implement it.
So Govind, quick question. When they are giving you questions in the interviews, they give you a system without any internet? That's it?
No, no, definitely they will give internet. It's like a remote interview I'm asking. They will make you take the screen access of yours and you have to enable your camera part, right? And then you will have 20-25 minutes of time to complete the task. Okay.
But we can't take any help from the internet, right?
Yes, your screen will be shared actually, no. If you
Okay.
type anything else, then they can see that. Okay. And some companies also ask to use camera of your cell phone also. That will put behind.
Nice. That's good.
Hey, I I think I need your help for a reminder. Can you remind me how I determine my input shape again?
Input. So do you have that ANN file with you? ANN hands-on file?
What? Which one?
A- ANN hands-on that we have done.
I'll have to look for it.
So go to the LMS portal, okay? There we have done the ANN hands-on, like last, it was on Sunday, last Sunday notes, okay? You just upload it to the LMS, okay, collab, and you can see all the steps what I did over there.
I see there is one here on 11th January, which was
Or you can
last.
just see, you can also open the solution, what I gave you, okay, in the drive. You can visit that solution, okay, for that step where you have the issue only, okay?
Oh, I thought you said we refer the solution after. Okay.
Solution is
Uh,
there.
so that means I have to download it.
Yeah.
Uh, yeah, because I remember, I know the input shape is determined by the, was it the size of the image when we were comparing to an
See,
8 by
for
8?
next 20 minutes, I will not help anyone since I'm just checking you are able to crack the interview or not. Okay,
Uh,
that is the reason I gave the specific time.
oh, okay, okay.
Check.
Govind, a quick thing.
Steven?
So basically, I have the results. So, but they differ slightly. Like my accuracy 86 point something, and in the fire it would be like 87. Does it matter,
No
or should
problem.
be?
No problem. In machine learning, deep learning, accuracy will vary. Okay, it cannot be same. Depending
Yes.
upon the runtime, the speed, everything. You worked it?
Yeah, it is working for me,
Perfect. Perfect.
but I need more practice.
Did you require solution?
I'm sorry.
Did you use the solution also?
Like I was comparing my results, but I need more practice. I think this is very important, like ANN and CNN in the interview
Yes, this is
and
the
in the
main
marks.
questions actually. When you say, deep learning processes and NCN is the basic stuff they ask, right?
So go with the quick question. Like I understand that we are using the existing database or existing data sets, but can they ask this question that where you have implemented this actually?
See, when you talk about the real case scenario, when you develop any application, that is something which
Yes.
is only possible when you go for the companies and all, right? But in the starting
Yes.
level, like the companies which is coming up and they ask question, they only ask for the application side of it, right? That is
But
what.
can they ask that where you have because you have like 5 or 10 year experience, like if we make such CV, where you have implemented ANN and CNN
No. See, that experience will belongs to AI only in that case, right? If you have some other experience, so that experience will not be a point here in the case of AI. You will be still treated as a fresh part, right? That is the
Right.
reason.
But what if they ask in AI experience only like 5 years or 6 years experience?
So see, there are different job roles coming, right? Some companies ask for previous experience, like you will be directly deployed with the project. Some companies go for the fresher one, okay, where they don't consider, they ask for experience, but not specifically in the field of data science and AI, right?
Like suppose
Like
if they ask in the field of AI and ML, like if that is
then
not for
you
refresher in
see,
ML.
yeah, if company is asking for 3 years experience in AI, then you will not apply for it. Simple reason. Okay, then you will not be applying for it because their level of questions will link with the project that you have worked for the previous organization, right, Janet?
Yeah, true, Govind. But see, suppose currently suppose I'm working, right? So currently I can say that I implemented some A and ML and I want to go as an experienced then in that case.
So in that case, you will be mentioning the project that you have solved in your company specific. Okay,
True.
and you should
Yeah,
have a
true.
good
So can you just give some examples, real-time examples where in your company where you used ANN or CNN?
okay. See, when it comes to the part of uh, spam detection, right? So we have built one model, okay, where we pass different emails or any text part that can able to predict whether the spam email or the piece of text containing spam part or not spam, and some sort of transactions are involved. Okay, we were working with the Citibank project, so we used to get the real time transactions of credit card which people used to make on daily basis. So that model could able to predict like unusual behavior in the transaction, okay, and those transactions comes to a different category, and then team go and manually evaluate one by one all those transactions just to see are they fraudulent or not. And 50 to 60% time those transactions are fraudulent because in many countries, if you say not in just one country, even all the countries, most of the fraud happened on credit card itself, right, Jinal?
Yeah, true.
So if you talk about real time, so this CNN actually used for CNN and ANN model. I would not say CNN. ANN was the main model where we have used for credit card spam detection.
Mm, that's security compliance. Uh,
What is the difference between, I mean, ANN and CNN since I
You
missed
have to watch
yesterday's.
you have to watch yesterday class recording. Okay, in the first 1 hour we discussed
Okay,
that only. Okay,
sure,
finish.
sure. Okay,
So
once I get the recording, go through it.
Govind, how
Yeah.
long the AI is in market? Actually, they are really looking for 5 year of experience, or the market is open? Because I recently started, you know, having like, more kind of views about AI, and AI is in market. So I never heard that much before. So how long it's been in the market, and how much experience they're looking for?
See, if you look for the open market, right, when you start applying by your case, you will find different kind of job role where they are different experience part. Since the chef team also, I think, communicated to you for the placement part, right? They have a recruitment firm and multiple clients, like MNC and startups are associated with them. So they will be providing you the opportunities, okay, where companies are not looking for your previous experience in the AI and ML, right?
Yeah,
So
that's
you
why
will
I'm
be
saying
applying.
it. That's what I'm saying it. Basically, this was like, I thought this is kind of getting introduced, and it's gonna be like next, biggest thing to work, and you guys gonna be kind of, the head of the game if you start right now, because this is a new thing getting introduced, and
Of
it's gonna
course,
be.
of course it is. Yeah, and many more things are coming on the AI part. See, on daily basis, you find something new, right? And many people are yet to be onboarded on internet. That is the reason. And so,
Yeah.
in short, if you talk about the placement part from the chef team itself, so what I know, they will provide you the placement opportunities where they will not count your previous experience in AI specifically. And if you have that, you can communicate that I do you do have you have worked already with some AI projects and all. So they will be giving you that opportunity where 1 or 2 experience, okay, can be counted.
Okay.
But if you talk about the market, again, every company has for all this sort of job roles. Okay.
Okay.
Hey, so you said after this project we have to submit it, or what should we do next?
So no, this is not the project. This is just an assignment I given just to
Oh,
evaluate yourself. Okay, you will be evaluating yourself, like you can able
yeah,
to perform it or not. Okay,
yeah,
that's why I gave a solution
actually,
also. Submission is
yeah,
not required for that.
I know. I just commented on the model in the first model because of the question I asked earlier about the input shape. So it's something I need to revise. Other than that, yeah, I think I got the best of like probably like 80% of the lines without using the solutions. So yeah, that was pretty cool. Thank you.
Okay, everyone.
Go
Okay,
Govind, one question. So
just speak.
can we
Yeah,
also share our projects like on platform like Tech Overflow, like
you can
Stack
just
Overflow or
see better. No, better to share on GitHub. Okay, and that GitHub link you can paste on your resume part. GitHub is the
okay.
main portal. You will put, not any other platform. Okay, don't put on Google Drive or something. Only on GitHub. Just have a watch. Just watch 10-15 minutes of YouTube video how to operate GitHub and all. You will understand the flow structure.
Yes. But my question is just like when we are saving the file, should we save the file in then Google Drive or should we just save the file in
As of now,
desktop?
as of now, as of now, you can save in your also. But when you go for the companies and you prepare a resume, that time you create a GitHub profile for yourself.
No, no, sorry. My
Okay.
question is this: when we are accessing the file, like .csv file, we are accessing from the Google Drive, or we should be just placing the file in the desktop? How we should
No
have
problem.
both the
Either way is
CSV
fine.
and the
Yeah,
PWAB?
either way is fine. Either way is fine. It's up to you, your convenience, which suits up.
Okay. Okay,
Okay,
when the
you
time
can
comes,
put
I'll
any.
ask you again as well. Thank you.
So thank you,
Thank you.
everyone. Bye bye.